Today we are going to discuss errors and uncertainties. This is serial 1.3 of syllabus. Read types of errors and calculation of total error in a measurement. We have already learned in O-level the types of errors. They are systematic errors and random errors. The examples of systematic errors are zero errors, which can be positive and negative as well. Personal error of the observer, for example, reaction time. Errors due to instrument, for example, a watch which is running fast or slow. Wrong assumption, for example, the gravity value is 9.81 and it is erroneously taken as 9.91 or 9.71 or 7.81, then the error has occurred and that error is due to wrong assumption. Systematic error remain almost constant and can't be reduced by taking large number of readings. That is, averaging does not reduce the systematic errors. Number two type of error is a random error. From its name, it is clear that these errors can be different in values depending upon person to person or condition to condition. So the random errors are number one, parallax error or unnoticed changes in temperature while doing a temperature experiment, applying different pressures to instruments like micrometer, screw gauge, and so on. In our O-level, we used to record the measurements in a manner as shown, that is, length of a table is equal to 2.30 meter or mass of an apple is equal to 0.275 kilogram, etc., etc. There was no mention of error. But in A-level, we are supposed to work on the errors and uncertainties in a detailed manner and calculate them. So you must remember that errors and uncertainties are one and the same thing. You don't have to differentiate between them. However, in our next stages, we are going to learn the symbol of the error or uncertainty. Now, we also have been talking about least count of vernier calipers, screw gauges, laboratory thermometers, etc., etc. They are not new to us. Now, if we have to write down the same length which has been written as 2.30 meter in the previous page, we will write it down as length is equal to 2.30 plus minus 0.01 meter, and 0.01 meter means that the error is 1 centimeter. Similarly, mass equal to 0.275 plus minus 0.001 kg. The value of 0.01 meter in length is the error or uncertainty in length, and 0.001 kg in mass is error or uncertainty in mass measurement. Now let us do calculation uncertain quantities. I have taken two quantities, Q1 and Q2. Q1 is equal to 20.3 plus minus 0.1 units and Q2 is 11.0 plus minus 0.2 units. It could be any value. I mean, it could be length, it could be anything, but I have taken them as Q1 and Q2. Now, look at the red note. Fractional error in Q1 will be equal to 0.1 over 20.3, which is equal to plus minus 0.04, and fractional error in Q2 will be 0.2 divided by 11, which is going to be calculated later on in this calculation. Now, if you have got the fractional error in Q1 and you want to calculate percentage error, then you have to multiply the fraction with the 100. So we get percentage error in Q1 as plus minus 4%. Fractional error is one of the most important calculation in errors and uncertainties. Now, if we have to add Q1 and Q2, then their values will be simply added. That is, the value of Q1 is 20.3 and value of Q2 is 11, so we add them. And their uncertainties will also be simply added. The uncertainty for Q1 is 0.1 and uncertainty for Q2 is 0.2. So we get the answer of Q1 plus Q2 as 31.3 plus minus 0.3. So the rule is that in addition of uncertain quantities, their uncertainties are also added and written with the quantity. Going on to subtraction, again I have taken Q1 and Q2, and Q1 minus Q2 will be equal to 9.7. And just look at this is very important, that even when the uncertain quantities are being subtracted, their uncertainties will come as added and written with the answer. So Q1 minus Q2 is 9.3 and the error is 0.2 plus 0.1 is 0.3. So the answer in Q1 minus Q2 will be equal to 9.3 plus minus 0.3 units. So we have come to a conclusion that in addition or subtraction of uncertainties, errors are added. Now we come to multiplication of uncertain quantities. Again, same Q1 and Q2 has been taken by me. Q1 is equal to 20.3 plus minus 0.1 and Q2 is equal to 11.0 plus minus 0.2. So for multiplication, first of all, we multiply the quantities. When Q1 and Q2 are multiplied, that means 20.3 is multiplied with 11 and we get an answer of 223.3. And we write down plus minus absolute uncertainty in Q1 and Q2. The symbol for uncertainty is also shown in green color and then black color as well. Step 1 in multiplication is you write down fractional uncertainty in Q1 multiplied by Q2. That means whatever calculation is to be done, its fractional uncertainty is to be written on the left side of the equation, and then on the right side fractional uncertainty in Q1 plus fractional uncertainty in Q2. That means the fractional uncertainties from the values from which the answer is being calculated have to be added up. Then we make equation, and the equation is uncertainty in Q1 multiplied by Q2 divided by Q1 multiplied by Q2. This is fractional uncertainty in Q1 multiplied by Q2. And then we write down uncertainty in Q1 divided by Q1 and add uncertainty in Q2 divided by Q2. These are the fractional uncertainties in Q1 and Q2 respectively. Then we put in the values and calculate. The sum of fractional uncertainties, which is 0.023107 dash dash dash. We are not going to round up at this stage. Then we take 223.3 on the other side, multiply and get an answer 5.16, and we write down plus minus 5 the uncertainty in the multiplication of Q1 and Q2. Please remember that uncertainties are written in one significant figure mostly, most of the time. Okay. So step 3 is writing of the answer, and we write down q1 q2 is equal to 223 plus minus 5. Please note that the uncertainty will be in the least significant figure of the answer, that is 220 in 223. 3 is the least significant. I have written the answer in 3 significant figures because if we look at the data of Q1 and Q2 on top of the page, both of them were in 3 significant figure. So this should be the right answer. The value plus minus 5 is also called the absolute error or absolute uncertainty in a calculation. I have also calculated percentage uncertainty in the multiplication of Q1 and Q2, which is plus minus 2%. Similarly, if you divide 5 with 223 and multiply it with 100, it will give you 2%. All the steps that were required to be done in this calculation are also shown to you, but when you are doing the question in examination, you will have to see as to how many marks are allotted to the question and show your steps accordingly. Now we go to next page, division of uncertainties or uncertain quantities. Again, same values have been taken by me. On the left side of the page, I have done Q1 divided by Q2, and the same calculation that is on the previous page has been done by me. Here 20.3 has been divided by 11, and plus minus uncertainty in Q1 divided by Q2 has been shown. And then in step 1, fractional uncertainties have been taken in the same manner as were taken in the last page while doing multiplication of Q1 and Q2. So I have taken value from there, and actual Q1 over Q2 works out to be 1.84545, and when I multiply this all, I get a uncertainty in the value of Q1 divided by Q2 is equal to 0.04 as shown in step 2. Actual value of this was 0.03847. I have rounded it off in this, and then written the answer of Q1 over Q2 as 1.85 plus minus 0.04. Can you see that the error is shown in the second decimal place because the value of Q1, Q2 was up to second decimal place, and 3 significant figure again have been taken in the value of Q1 over Q2. On the right side of the page, I have calculated Q2 over Q1. I'm sure you will be able to understand that. If this lecture of mine has helped you understanding the concept of errors and uncertainties, kindly like my channel and subscribe. Thank you very much. Just to remind you, I am going to do some past paper questions in my next lecture for this concept, and when I upload, kindly go through it and practice a lot. Thank you.